Ashwini Agarwal, SID India Advisor, to chair the next session. Thank you.
Thank you, Shambhavi. And we just doing a minor reshuffle. I would like to invite and introduce Dr. Morgana Ribas. Dr. Morgana is the senior general manager of R&D at 3M, a reputed company where all the M's stand for materials and all the work that they do. They make a unique set of products for the display industry. And Dr. Morgana is the right person to talk about it. She has tremendous experience in the industry. I know she was with Alpha McDermid. And Morgana, your audience, if you can take the stage.
So good afternoon, everyone. Let me try to stay within the time here. So it's something that the organizers always appreciate, right? Is some video playing? No. No. Oh, okay. Thank you. Because I cannot see the screen. So that's why I was asking on that. So I lead the R&D team for display and electronics for 3M in India. And I'm located in Bangalore, which is our largest R&D center in India. And today I'm going to talk a little bit about functional high-performance materials. Now, optical science is used for changing in direct light. And the optical films that I will be talking here today, they also can be used on a range of display applications, either from TVs, laptops, mobiles, wearables, right? And I will start this discussion about talking a little bit about these optical films, their applications and solutions, and also specifically talk about 3 materials that are current and emerging solutions to support the display manufacturing and assembly, which are optically clear adhesives, OCAs, thermal interface materials, the TIMs, and electromagnetic interference, or EMI shielding. Now, optical films, they enable this brighter, better, and more efficient display technologies. But one of the things that I want to highlight that is basically underlying everything that I was explaining here, it's about the 3M technology platforms. And by the way, this is the only part that I talk about the company because it's so fundamental for these products. Because over 100 years of innovation, 3M has created several technology platforms. So why this is important? Because basically we can mix and match all these different technologies to give additional functionality to these materials. For example, we can combine adhesives, electronic materials, microreplication, light management, for giving additional functionality to those films, enabling a wider range of applications. And even further, in future, we can bring additional technology platforms into those films to give an even further functionality to them and enable further applications. Now, when I started working, I had a CRT display. Right? Whoever has seen and worked with them remember the size and the type of contrast and resolution that we used to have that. And now, when we think what we have, a lot of people working on display technologies, and from our side working on the films that support those display technologies, have been working to make all those changes, right? And now we have TVs, commercial displays, tablets, wearables, right? Everything is much more integrated in our lives. And what is really important for us is looking further, right? What is really yet to come is these displays become even more integrated into our everyday lives. But for that, if we have displays that are maybe flexible, foldable, moldable, right? We also need to change the type of films that we are using to support those displays. Now, this is so important that I actually wanted to read this sentence here, because we use optical science to make displays brighter, lighter in weight, thinner, cooler, and more energy efficient. So this is the very basic of all the films that I will be talking here today. And some of our films are so complex that they have hundreds of layers, and we have a film that is up to 900 individual layers, and each layer has a function. Because like I said, we have all these technology platforms that can be combined and all these different functionalities in one single film, as thin as a piece of paper. Now, one example that I really like is how to enhance this human-machine interface is in automotive. Because for automotive, it's when we think about all the automation vehicle, autonomous driving, and increase and enhance safety that these automobiles are bringing to us now. There are several small things that we don't really realize, right, how important they may become. And for example, when we are on the road, I just think about my older cars, right? And we had a lot of sun reflection, or even two-wheelers, that we look at those displays and basically we cannot read under the sun because of the sun glare. We cannot actually see what is displayed there in those older displays. But there are films that help us to have fewer reflections, brighter displays, which also make us to be safer on the road. Now, a couple of other examples on that is when in autonomous driving, we do have infrared cameras that are hidden on the displays. And those cameras, they are tracking the eye movement of the driver to make sure that they are paying attention on the road, right? So we can use some of these sensor materials to camouflage those cameras so the driver doesn't know actually where that sensor is, so, or it would be a kind of cheating, right, if we knew where that camera is. So it really can track and make sure that, so the system can make adjustments to make sure that the driver is paying attention to the road. And also, when we think about all the, how far the automotive machines have come, right? From purely mechanical machines to now machines that have dozens or hundreds of sensors and cameras, especially when we are moving towards autonomous driving on that. So some of these sensors, several of them, are placed on the exterior of the car, and they are exposed to dirt or moisture, and these optical films, they can help to protect those sensors, extending their life and ensuring their functionality. Now, as a scientist, what really strikes me is that the same technology, right? I mentioned about the technology platforms. The same technology can be used on a wide range of applications, either from very large displays or devices as small as those who are going to be using VR or AR headsets. So now I'm coming to the second portion of my presentation today, in which I will talk about these three specific materials on that. And I'll start talking about the optically clear adhesives, so OCAs. So OCAs are basically film-based adhesives that they match the refractive index of the optical films. And I don't know if you can see the mouse here, but because they are placed in the place of this air gap here between the cover glass and the liquid crystal in the case of the LCD, right? Because of that, the light actually moves seamlessly and improve this contrast and ratio brightness from this image on the from the left to the right on that. Now, one interesting thing is because of OCA cannot only doesn't need to only be an improvement on the optical properties, but also can combine other properties like electrical properties. We can also use layers in these films that are used to mitigate EMI, or even the mechanical properties because of the adhesive backing. We can also give a little bit of additional strength and mechanical strength to the whole assembly of the device. So for automotive OCAs actually is even better example of how these materials can really support future designs. Because when we look at automotive, there is a lot of trends in having it more formable and moldable, in which some of the switches, right, that instead of having buttons, we can also have these switches into displays that are just moldable to a certain design in the automobile in there. So the second material that I like to talk about is thermal interface materials. Now, thermal interface materials, they are placed between a source of heat and a heat dissipator. Now, this is one example here. If you see this image on the left side, that we have at the bottom, we have this electronic package, and at the top we have the heat sink. Now, this thermal interface material is placed between both and help to direct the heat away from the electronic package, which ensures its durability and also help preventing further damage to the electronics in that. So, but why do you need to use this thermal interface materials? Because even the most flat surface will have these air gap pockets here, as we see in this picture. And air is a poor thermal conductor, and it's a very inefficient way to manage the heat that is coming from those devices. Instead, we can use these thermal interface materials to not only fill this gap, air gap, between these two surfaces, but those thermal interface materials, they can also be further tuned. So if additional functions, additional properties, and with that we can have tuning of this thermal conductivity here, as in this example here, but we can also adjust the softness, the hardness of these materials, so we can also adjust how much formable these materials are. And also the adhesive, of course, what is the adhesion strength that is required for a certain application. As all materials, there is always certain trade-offs, right? When we look at material science, many times we have trade-offs. It's very difficult to have a super material, but that's why it's so important to have this ability of tuning these various attributes so we can have a more efficient thermal management while ensuring that we still have appropriate adhesion and other properties that are required for these materials. So one example here is on a display of an appliance. So we can use a thermal interface material, either attached, there is a little bit of echo here on mine. So either directly attached to the PCB to extract the heat, or also between the PCB and the sensors to help to extract this heat away from the electronics and helping us to not have those warm displays, right? Now I have only 2 minutes, and EMI, electromagnetic interference, is generally a technical seminar that we take 2 hours to go through. So I will just have a very brief 1 minute point here on this, because EMI actually is extremely important. And it's basically the noise that we have from these electromagnetic waves And when this noise is higher than the signal strength, that's when we start having issues, right? We are going to have reading errors, we may have data loss, we may have issues of delayed or incorrect readings, and several devices actually, they are mandated to have a control of this EMI. And when we think about data loss, right, incorrect readings, and we think about all the applications where these displays are going, from general electronics, but then we think about automotive, where we're looking at the safety of people, or aerospace defense, or even medical devices. So it's very clear the importance of controlling EMI. And how can we mitigate EMI? We can have, we have two types of solutions. One is the EMI shielding and grounding, where we use these conductive tapes to actually reflect the EMI away from the device, or we can have EMI absorbing, in which we take the EMI and transform in an insignificant amount of heat. So very quickly, these two examples. On top one, we have this electrically conductive tape, in which we do have a chassis for grounding. So this metallic chassis, it serves as the grounding with the conductive substrate through this electrically conductive tape. But in addition to the bonding that this tape is bonding these two parts, is giving the grounding, is also giving the EMI shielding on XY direction. And when we think about this electrically conductive tape, double-sided tape, between two metallic plates, then we have even on the Z-axis direction grounding. So my time is over, but I just like to show this exploded view of the display, where we can use so many different applications, either from the display module wrapping, or also for the EMI shielding, PCB grounding, and the EMI noise suppression. Now, out of everything that I spoke here, and I'm not going to read this summary here, it's just that it's really important to have materials that are reliable, that they are functional, right? They have high performance to really enable the next generation of display technologies. And I like to close only on this slide, because I feel that everything that we do in science should be applied to life. Thank you. Thank you for your time.
Thank you, Morgana. And may I invite Dr. Sorry, Prasad, you should be a doctor now. Prasad Madhavabhotla ji from Applied Materials to take over and complete the presentation he was to make in the morning. Please.
Good afternoon. Okay. Okay, so yeah, post-lunch sessions are always difficult, right? But I will wake up with thing. If you want to buy, huh? Yeah, in this one only, this one only. Yeah. Yeah. Okay. If you get a OLED TV for LCD price, will you buy? Yes. Okay. So Applied Materials is working on that to reduce the large format OLED devices into a cost-effective kind of stuff, and also that the price maybe, I think now it is around 3x if you want to buy a similar kind of display of OLED what you are getting for LCD, and now in future you will get maybe 1.1x, something like that. And for that we recently introduced our new product, that is Max OLED. It is maximize performance and then minimum cost. Okay, with that, so I hope you all woke up. So let's continue the presentation. Here I'll be giving what are the inflections which are going further into the display industry. And before that, yeah, we learned about different kind of displays and OLED, LCD and all. So here in my talk, I'll be giving a little bit comparison of what is actually the equipment suppliers are looking into, so that the end consumers can make a kind of a relevance, okay, which technology we need to go. And also for the investors to see that whether they need to go with a generation 6, generation 8, LCD, OLED, micro LED. So I'll be covering a few of the thoughts on that one. Yeah. So applied materials, I think you see everywhere in Semicon you are seeing, and one of the people from the Semicon, they are saying that, okay, we might have named this particular conference as Applied Materials Conference. Yeah. Okay, so moving further, so I'm just quickly going into the right subject. That is, okay, if you see that the OLED, everyone is talking about it, and I'll be talking more on that because LCD, I think it is almost like the inflection is coming for the OLED stuff, and there will be some kind of a changes which will going to happen. So OLED, when it comes, I think we have not yet seen the OLED TV stuff, but OLED IT is coming already. And then the next thing is the OLED TV. And also we are seeing the OLED on silicon. So that is for the AR, VR kind of devices which we can use it, and also micro LED. So it all depends on which technology is always depends on where you want to use that particular technology and what kind of the end application you want to use it. Coming to applied materials, as I said, we started long ago, around 50 years back, and then we have been helping the display industry, working with our customers in enabling these technologies. When it comes to the LCD stuff and all, so we have the deposition tools for the chemical vapor deposition, CVD, PVD, and also we have the EBR and EBT tools to check the pixel inspection stuff and all. So this will really help us. And so if you see, right, on your left hand side, you see an exploded view of how many glasses we need to use it as a back plane and then front plane, and what are the tools which we need to have it to make a display. It is a simplest form of representation of a display module. Coming further to OLED, it is basically the reduction of the number of processes which we are doing it, and it is really, see, you have one backplane stuff where we do the TFT stuff, and then we have one OLED, that is your front plane, and then we do the encapsulation stuff so that that becomes your OLED panel. So the process is becoming a bit simpler, but the initial investment is pretty high to enable this OLEDs into the high volume manufacturing. Coming further into the micro OLED, right? So it is even further reduced into the technical complication stuff and all, but the initial cost is very high. So due to that, the micro LED stuff is still, it is in the enabling stuff, and maybe for the very small displays stuff, we can still go with the micro LED, but if you want micro LED for a mobile and a TV, you can forget it. The cost is even much more exponential stuff, yeah. And so there is also one more thing is coming up. So applied, it works on different kind of technologies, and then it will see which technology will play a major role into it. So OLED on silicon is another new technology which is there, where we do the deposition and everything on the silicon. So applied has the tools which will make this particular OLED on silicon, and we have the OLED evaporator stuff to make it. So we name that particular our evaporator as Max OLED. Yeah. And coming further, LED on silicon. So this is also another kind of a stuff which we can see it using the micro LEDs. So if you see, right, the LCD, it's we have place, and then OLED, and the next technology stuff OLED on silicon and LED on silicon. So applied is playing a kind of a major role in each and every technology, and then watching out what are the inflections which are coming out in each and every technology. And what actually the manufacturing technology roadmap. So if you see, right, the size is one thing, so which we need to see, right, the 60-inch, 40-inch, 75-inch and all. But at the same time, so we need to see the form factor. Now you can see all of our mobiles, it's a curved display stuff and all. And also there are foldable kind of a displays, but these displays can be enabled with the OLED technology. So And for that, your backplane, we need to see that the electron mobility we need to increase with our low temperature polysilicon, LTPO, or a metal oxide stuff. And on the front plane side, so we need to either go with the OLED or else we can go with the micro LED. So there are different kind of options available. Yeah. And the next thing is making it rigid to the flexible. Right? So rigid display and then flexible. Flexible is something now, it is not too far, but we will see in the future more and more flexible display stuff. And furthermore, so if you see, right, 2D to 3D, I'll be talking in my next slide how it is. So this is the inflection wave which always see in the display industry. And CRT, it is gone, and LCD, it is still existing. And then OLED, it came already into the mobile, right? All our mobiles pretty much in the AMOLED mobile stuff. It's already replaced the LCD stuff. And the next thing is it has to replace the TV and monitors and all those things. But it will start with basically the monitors, and then it will go to the TV. And in between, I think morning, Mr. Krishnan saying that, okay, people are talking about micro LED, different kind of a technology, and which technology people need to adopt. And for the technology, what you adopt, so we are actually seeing it, that OLED, the maturity stuff and all, it is pretty much coming. But micro LED, the maturity for the high volume manufacturing is still not there. I think we need to look how far people can come up with some new inventions to make it happen. And always the future is the 3D display, right? 3D not with the glasses, but without glasses, how you can have a 3D kind of a display stuff. So this is how the industry technology inflection which we are seeing it. Coming majorly, I think everyone is talking about OLED, micro LED. So what I said is, okay, let us talk a little bit more on what are the different kind of technical advantages stuff and also the cost advantages stuff when we see these technologies. Okay, yeah. Okay, so let me go directly into the large area stuff and all. So in the IT stuff, right, I think people were pretty much seeing that how can we have a Gen 8 fab for the OLED stuff, right? And the main here, the bottleneck is the mask. Having a big kind of a mask for a Gen 8 size is, it's very, very difficult. And Applied has come up with a new maskless technology. So that is litho-based stuff, and that will actually enable the OLED, whatever I'm talking about, right? How we can bring down the cost of and all. So with this maskless OLED evaporator, we can enable these things. In the interest of time, I'll just go further. Okay. So directly into the comparison stuff. In the other presentations also, we have seen some of the comparisons of different technologies. But here I put cost also into the picture. So if you see, right, the LCD TFT, cost-wise, it is very green. I think it's very cheap now. Yeah, it's like a CRT, right? How it ripped off, and still LCD is existing. But the thing is that if you see the resolution, it is okay, but the power efficiency, brightness, and then contrast ratio stuff and all, still I think we have the difficulties with the LCD TFT. But if you take the OLED, then it is everywhere, it plays a better kind of, it is not totally green, but when it comes to the resolution and refresh rate stuff and all, OLED is pretty good. But when it comes to the cost and all, still a lot of work to be done by Applied Materials or the equipment suppliers to bring down the high volume manufacturing cost. But micro LED, as I said, everywhere it is okay, but the cost wise, I think there is no good solution to make it cost effective. It's way far now. Yeah. And what we need to improve to enable these things is basically we need to improve the yield and we need to do the cost reduction stuff. Yeah. And I'm also giving a little bit more comparison on the ultimate display stuff and all, the pros and cons in a simplest way, right? The LCD, there is a huge maturity for the India to take something. Then if you want to enable, then the matured low risk kind of a stuff is having a LCD stuff. And OLED, the main thing is that the scalability and the lifetime stuff, unless we do, because no one want to buy a TV change TV every 3-4 years, right? I think our Indian mentality, we need TV for a decade, right? Almost. Yeah, so I think we need to pretty much see that. Mobile, yeah, we can, but TV, we need at least minimum 5 to 8 years. Yeah. So with that, I think there is a lot of work to be done. And then micro LED stuff and all, as I said, the pros are pretty much on the technical advantages stuff, but when it comes to the technology maturity and then cost, we are not there yet. Coming further, so why people need to go with the micro LED displays? So there are certain kind of a comparison stuff which we have, but the value technical advantage is pretty high, but when it comes to the cost, so that is the reason the micro LED for the small displays, it is pretty good. And there is one more technical advantage which I am showing it to you is that when we go with the micro LED, so we have RGB pixels, but the size is so less, you always have some more room to add one more pixel. And that pixel, we can pretty much put it as a sensor kind of a stuff. Simplest example is your car dashboard, right? So if you have a dashboard, so which actually take the facial expressions of the driver, and then it senses, and then it gives alarm, okay, when the driver is falling asleep and all, right? So like that, we can pretty much use the display even for those things also, because there is a pretty much more real estate is available. So when we go with this kind of displays. And then future, yeah, it is a 3D. I'm not going further. So I'll take 1 minute to talk about Applied Materials India. So we are based in Bangalore, and that is the main hub. And also we have a few more locations where we have around more than 8,000 people working for semi side as well as the display side. So it is a portal together, yeah. And also Applied does a lot of investments into the R&D side, and huge investments we made in 2023 and 24. Even in the Semicon, we announced how much investments we are doing further and all. And we have the exploration lab where we do the process development stuff, and also we do a lot of reliability testing of the equipment. So when the display fab comes here, then we already have the existence here to support the display fabs in India. And coming further, right, the main thing is that we need to look both the things. So one is the OLED, how the momentum is going, and also we need to see micro OLED, how it is going, so that we really play a fair kind of a decision. And for India, it is very much important to take a better decision which one they need to go. And we all know about how the plasma display stuff has happened and all, right? I think we need to be a little bit careful. So, but at the same time, right, both are really emerging technologies, and we need to choose the right one. And Applied Materials has a unique advantage here. That is, it has experience in semi side, and also it has experience in the display side. So we can always leverage the learnings which we are getting from the semi side into the display, and then display side into the semi. So that is the unique advantage which we have, and we are already playing a major role. And 2 days back, Dr. Prabhu, he presented and he said that we could able to compress the decades of 1 decade of development in 2 years in India. That means we are late, but we are latest, right? So like that we can pretty much do in the display side also. And coming further, so for the India to go, right, I always still feel there is a huge window of opportunity for us for the display fab, but we need to have a good technology partner, good investor. Government is already providing the subsidies, and also we already seen in the morning talk. So only thing is that we need to see which technology we need to go and which size we need to go, right? And always we need to see that, okay, what is the current market dynamics and where is the user base which is looking. So we need to pretty much see how much is the consumption stuff, and we don't want to go with a old technology where there is no future, right? And at the same time, so my final thought is that India, for the fab to happen, right, we need to have the right technology, and then which fab generation we need to have it. For the equipment, already we have Applied Materials, as I showed you, in most of the deposition tools and inspection tools we have. So finally, I think I see that when I come next time here, I want to see that, okay, a few announcements on the display fab. Yeah, thank you.
Thank you, Prasad. Really appreciate your saying it with the national colors out there. And I will like to invite Charlie Wu, our speaker from Corning, to take over and present on Corning's propositions.
Okay, good afternoon, everyone. Thank you to SID India to the opportunity. Let me speak with all of you. It's an honor to join this community of these innovators, engineers, and marketing leaders. So my name is Charlie Wu, and I work at Corning. I'm focusing on trade and understand the display technology trend, so that we can, in Corning, we strive to understand this display technology dynamic so that we can grow with the industry. We know the India display industry is growing fast. So today I want to share with you Corning's view. What is the key driver on the display technology and the display market trend? Okay, so the global display industry is entering a new phase of growth. And now we are seeing a stabilization in baseline consumption and a surge in premium trend, in premium segment. So what is the premium segment? What is the key driver? Today, I want to highlight 3 topics. The first one is super large size LCD, or you can say large format TV for LCD. And the second topic, we think this also the important driver is high spec IT. IT means here IT means notebook, tablet, and monitor. And for the future, we thought the new driver will be the AR, VR, and a very small size display, this advanced display. Okay, so here is today's agenda. The first one, large size LCD growth. This is a very important topic. And the second is OLED penetration into IT segment. Number 3 is progress of AR, VR, and finally, I will close with Corning's role, how Corning supports the industry growth together. Okay, large size LCD. Why we say the large size LCD is very important? Because we know the LCD panel, LCD display, the revenue is continuously growth. Why? Why can it do that? Actually, the shipment is not continuous growth. That is, rely on the area, rely on the size. Because of the size, the area is continuous growth, so that the LCD revenue can continue to grow. So we thought that is a very important point we should know, that is super large size LCD. As you can see the table, the 65-inch LCD now grows from the niche market to be the mainstream. So that average generally say the LCD TV size every year will increase one inch. This is continuous, ongoing. So except the super large size, for the premium TV, here we highlight 3 points. The left-hand side is ultra-large size LCD we just talked about. And the middle one, HDR. HDR means high dynamic range. It means high brightness and high contrast ratio. So for LCD TV, the advantage is super high brightness. But we all know OLED. The OLED advantage is high contrast ratio. So here is the competition between LCD and OLED in the TV segment. The key the competition is HDR. So on the other hand, LCD need to continue to improve its contrast by the mini LED backlight using the local dimming function. And for OLED need to continue to improve the brightness. So we know the most new OLED TV can use more and more candle stack, but the cost is also continuing increasing. And right hand side here, we emphasize the anti-glare TV. Anti-glare TV means we can see this year's premium model for the premium TV. They introduce anti-glare function to let the TV can see clearly in any different kind ambient conditions. This is a new promotion point for TV. Okay. The second topic we want to highlight that is OLED penetration in IT segment, notebook, tablet, and monitor. OLED is rapid penetration into IT market to meet this demand. Panel maker are building new Gen A size OLED fab. We know in China, in Korea, now they are investing a lot, many, at least 3 to 5 new fab. So as shown in the cartoon on the right, Gen A size glass is more efficient than smaller size. It helps make OLED. We can make more OLED panels at lower cost because of higher glass utilization. So the penetration rate, we know the penetration rate may be around to 2029. The OLED IT penetration will go up to 15%. So just like the chart shows, the capacity also increase as well. So what do consumers want? They want a display that is the thin, light, durable, with long battery life and easy to read anywhere. So what must panel makers design? They need display with higher resolution, higher brightness, and more power saving and stronger durability. Using the new technology like tandem OLED, COE, new TADF material, and AGAR function, etc. So we need more technology for this kind of advanced display, OLED IT. Then that implied we need to get more challenge here. We need to have a higher process temperature because we need to the precise TFT process, higher temperature process, and shape change during the complex TFT process. So here, learning how to help our customer, how to help the industry to address this issue. There are 2 areas. One is in the display panel. We can provide a very advanced glass substrate, even very high temperature. The stability of dimensional is very good. Second, we can also provide the glass on the IT device so that the IT device can be more durable and more power efficient. So that is what we would do with our customer. So we just talked about what is the hot topic now in technology, that is OLED IT. And for the future, we believe that for the future, the next gen, we think the AR VR is the most emerging technology. It must have more opportunity. With the rise of AI, AR glasses R&D is booming. For AR, the most promising display technology is LED on silicon because it needs to be very light, very bright, and ready for outdoor use. So it needs to very high brightness and a very small size. As for VR, high-end device use OLED on silicon, but most mainstream device still use glass-based LCD, rely on the cost-effective. So OLED on silicon is not yet widely used now. Most mainstream VR headsets still choose LCD because it's a cost advantage. But LCD faces a key challenge that you can imagine that if we wear a headset, you need to see just like a TV or a movie cinema, but you need to shrink it. You need to squeeze the very big TV into the small headset. So we need a very high pixel density on the display. So that means we need to very complex TFT process. We need to a very precise TFT, very precise manufacturing process. So for this kind of advanced display, the glass, the dimensional stability of the glass substrate becomes very important. So that is why we want to say Corning how to help this advanced display. What is Corning's role in this advanced displays? As you can see, this is the fusion process used to make a precision glass. The step including melting, forming, finishing, inspection, delivery. This process was invented by Corning. This core technology allows us to mass produce ultra-thin, highly uniform glass. So it shows Corning's unmatched expertise in material science and optical expertise. So that's we use this kind of fusion process to design different kind of device glass to fulfill the different advanced display needs. So next, I will introduce what is our products. Just briefly talk about this. We have today I want to share three topics, three products. The first one is Corning's Eagle glass. This glass is our flagship product and is an industry standard as well. It supports large size up to Gen 10 size. Gen 10 size is the biggest LCD fab in the industry. And this glass is ideal for LCD process from amorphous silicon TFT process to oxide TFT process across all sizes. So the feature is with low density and the thickness from 0.5 millimeter to 0.25 millimeter. Number two is called Ultra glass. This glass is our most versatile solution designed for broad range of processing temperature. It supports process from the top end amorphous silicon TFT to LTPS, low-temp polysilicon TFT, and it's excelling in oxide application. So the application is very broad for this product. Okay, the final one is Lotus NXT glass. It's our most advanced glass. We just talked about the AR/VR, very high pixel density, very advanced a device, in that case, most of the time you will need this one, NST glass, the advantage glass. It's designed for high temperature processing that can keep its shape very well. So far, the glass has been used in nearly 3 billion OLED smartphones. Use this kind of glass. Okay, next slide. Finally, I'd like to say this. Our customer, panel makers, don't just see Corning as a supplier. They see us as a co-innovator. Together, we are shaping the future of display technologies. Thank you for listening.
Charlie, really appreciate that session. I really loved the part about the AR/VR glasses, and maybe we'll have a discussion on that separately. But let me ask Divyanshu. Oh, Divyanshu, there you are. Friends, I have Divyanshu Gautam here, Senior Director at Corning, and the Gorilla Glass Division. Is it your group under which the Optimus project would?
Yes.
The right guy. The 1,000 crore investment, and he's the right guy to talk about it.
Thank you, Ashwini-ji. Thank you, SID. And good to see still some of the colleagues staying back after that, very delicious lunch. So we've been hearing since morning about, the displays are the windows to the world. And in specific, I'm going to talk about the element of this window that we interact pretty much every day. In general, we touch the glass of the smartphone, or what we call the cover glass, which is the top layer of the display. Functionally there for providing mechanical strength, or for providing cover to the electronics inside. And we, on an average, touch it about 2,000 times a day. So it better be something that you should be comfortable carrying in your pockets, maybe occasional drops, and should be able to withstand some scratches that you may incur upon it by using keys and coins inside your pocket. Just one slide on slightly different than what Charlie said. So the glass that Charlie talked about is the glass that goes inside our display stack, inside the display stack, somewhere at the TFT display cell level. And the glass, Corning's Gorilla Glass, is the glass that goes on the covers, on the cover material. This is a product that we kind of invented somewhere around 2007, and in the last 18 odd years, every 2 years or less, we have been coming up with new material. While you may think that a Gorilla Glass, let's say 3 versus 5, these are just nomenclatures and way to command a price premium, but these are fundamentally new material that Corning has invented every time we have brought a new glass to the market, primarily trying to address 2 of customers' concerns, or 3 of customer concern. One is drop advantage. If you drop your device, you would ideally not want it to break. Second is scratch. If you put it with keys and coins or other stuff in your bag, ideally it shouldn't pick scratch, or it should resist scratch. And the third is optical properties like anti-reflection that some of my colleagues talked about, or anti-glare that Charlie was talking about. Especially in 2025, we have had 3 new to the world innovation come into the market in the form of Gorilla Glass Armor 2, which was on the S25 Edge device, Gorilla Glass Armor, which was on a Motorola device, and Gorilla Armor 2, which was on the Samsung S25 Ultra. Now, specifically talking about, you heard from a lot of my colleagues, from my counterpoint industry colleague as well, and Dixon, that Corning has done a joint venture with Optimus. So, the opportunity that we saw in India was that we have been talking about a lot of the display components coming into India, or being 100% imported into India, right? And I'll take you into a little bit of a reason for that. So if you can bear with me from the right-hand side of the chart. So right now on smartphones, there is about a 15% duty and a 10% surcharge, makes a lot of economic sense to do the final assembly in India. On display module as well, government introduced a duty a few years back as part of the phased manufacturing program. Again, the idea was that the assembly should happen in India, and there is a 11% duty and policy incentive support in the form of ECMS, that if you do the assembly in India, you get certain PLI advantages. But on the other components, like cover glass or cells, there is right now no duty. There is policy support in the form of incentives, but there is no duty. There are no barriers as such to import it into India. So you could look at it from two sides. It's two sides of the same coin. Is it an opportunity or is it a challenge? We thought of it as an opportunity, that why can't we do finishing of cover glass in India and try to bring this component into India. And that's the part that the Corning Optimus joint venture is trying to do. So we announced the joint venture in 2023. It's in Sri Perumbudur in Chennai. And it's a joint venture between Optimus, who are the majority owners, and Corning, who is the minority owner, but the tech leader, trying to bring this ecosystem to India, because right now there are hundreds of finishers in India, but in Asia, specifically in one of our neighboring countries, but there are no end-to-end glass finishers yet in India. And Big Tech is going to be that first venture that will try to do that. Thank you. Just a glimpse of some of the stuff that is actually happening on the ground. So we are very close to finishing the civil construction, and we'll begin the equipment move-in. We are targeting sampling in Q1 of 2026. Now, I talked about the opportunity, but the opportunity doesn't come without its challenges. If that was the case, everybody would have been jumping into glass finishing, right? So why are still a few, one or two players who are trying to do this? So the ECMS, or the new incentive scheme from government, does have a PLI component for display assembly, which is good. And that's why my colleagues from Dixon and a few other announcements that will likely happen, they want to do more display assembly in India, which is a good starting point, right? If display assembly happens, it means either cover glass is being imported into India and laminated in it, and that lamination will happen, or and that expands the serviceable addressable market, or for Corning. But right now there is no barrier for cover glass to be imported to India, and that's why the burning question that we get from our colleagues in the display module industry or from the brands itself is, hey Corning, why should we take the pain of doing all this development and add complexity or procurement process? Right now it's all centralized. We can all do it from wherever we are doing in whatever part of the world, and we can just bring in or drop cover glass into India. So that's the question, that's the burning question that everybody is posing to us. Right now, day one, given that the glass finishers that are existing in those countries or in our neighboring countries, they've been doing it for about 15 odd years, and they are at, they are much ahead of us in the learning curve, right? So they have certain cost advantage, they have certain yield advantage, which we don't have day one, and we have to overcome that. So we cannot be on day one. It will be foolish of me to say that, hey, I'm price advantaged over my neighboring country finishers, and that's the reason you should buy it. No, that's not the reason. The reason today is you need to take a strategic call at this point of time, and we need support from the eminent folks who are on the dais, that how can we convince the brands, the value chain partners, the LCM players, or the display assemblers, that they should be looking at a source other than a very concentrated source, and probably not the easy path of just continuing to import cover glass into India, right? That without which the survival of the venture becomes very, very difficult. I would also encourage to brands and my display assembly colleagues that let's go to the government together. And once we have proved that, yes, this is something that can be done in India, let's go together and ask for a little more incentives for those players who are willing to localize, right? So we're not asking for barriers to be created, but we are asking for the pie to be expanded so that both the display module makers can get the cover glass locally if they choose to, and there can be more finishing units which can come into India, which will also create the meta skill, because a lot of the skills that Charlie talked about in terms of glass handling, we are literally talking about glass that is, pretty much as thin as this piece of paper, right? 0.33 millimeter glass, 300 micron glass, and going, further down. And you need certain amount of precision, you need certain amount of skill set to be able to handle that kind of a glass and generate the right amount of yield. That skill set should come to India. We strongly believe in that. And this venture is the first one which is trying to create that ecosystem, and hopefully we will have more glass finishing coming into India that can serve the display industry and also the cover glass industry. With that, wish us tremendous luck. Again, Corning, a leader in cover glass industry, we have been doing this for 15 plus years. Big Tech is our joint venture to bring cover glass finishing ecosystem into India, and we need partnership from the brands who need to believe that, yes, this is a product that they should source locally, from our value chain partners like Dixon and others, that they want to do it locally, and support from government in accelerating this localization by continuing to provide incentives and government support. Thank you.
Thank you, Divyanshu. I must again repeat, thank you, Corning, for getting that big project in. It may be small for you, it's big for India, and all these steps add up. I really hope to see the larger vision emerge out. And with your permission, I'll call the next speaker in, Dr. Priyadarshini from Horiba. Dr. Priyadarshini is the senior application leader from Horiba. And Horiba, as you know, is the world leader in analytical engineering. They have lion's share of the mass flow controller market. Literally all applied equipment is having their mass flow controllers as the precision component in their equipment. I'm stealing her presentation. So back to her.
Just 1 second.
Okay.
Yes. I don't know. Is it coming? Yeah.
There you are.
Okay. Thank you, Ashwini ji. And thank you. I hope I'm audible, right? Okay. Thank you, SID, for giving me this opportunity to introduce our solution. And all the best Corning team and all the leaders who are thinking to bring the display industry's manufacturing part also in India. And I believe, as the session also shows us, that for anything to build the supply chain, the ecosystem plays a big role. That anchors not only the demand, that anchors more opportunities. So Horiba is in that, we are in that perspective, Horiba is an ecosystem player. We are known in the semiconductor industry, but also in the display industry, we have our presence quite well in other organization of Horiba in worldwide. And today I will show our solution, or what role we play or what role we would like to play in our next generation displays. So I am Dr. Priyadarshini. I'm leading the application team in Horiba, India. I did my PhD from IIC Bangalore, and my background is semiconductor. And before we go to the main topic, I would like to take 1 minute to introduce my organization. So Horiba is a Japanese organization. We are mostly into research and development as well as manufacturing of different analysis and measurement tool. Our head office in Kyoto, Japan, and here I'm showing Mr. Atsushi Horiba. He is our current chairman and group CEO. Any interesting fact which I wanted to show you, I think it's very important also. Although our head office in Japan, but as you can see that our overseas sales ratio is 76%. I'm a scientist. I'm not interested in the sales number, but I'm interested in number. It shows that we have provided solution to almost all the different parts of the country. And remember one thing, different parts of country requires different market and different demand. So our solutions are adapted to different market requirements. That's why this slide is, although I'm from a scientist background, but I love this slide. So in total, we have 28 major R&D and production sites, and among the 47 group companies. And in India, we have 3 major facilities, one in Pune, another in Nagpur, and another in Haridwar. Other than that, we have our offices and local outreach to almost every part of the India, as well as SHARC countries. These are our core technologies. We started our journey with pH electrode, but slowly we have acquired our expertise in different technologies like spectroscopy. We are having our flagship products and pioneers in Raman spectroscopy and other spectroscopic tools. Other than that, as Ashwini mentioned, in semiconductor, mainly we are known for our mass flow controller, our fluid technology, where we hold almost 60% market share of semiconductor industry. In fact, Prasadji's equipment, what you showed, if you open it up, it will show Horiba mass flow controllers, just like Hanuman shows the Ram. Anyway, these core technologies we provide to mostly 3 segments: bio and healthcare, energy and environment, and materials and semiconductor. Horiba India, we started in 2006, and with many new initiatives. Today we are here with more than 500 plus employees and 30,000 installation base. We are working over not only India, also from the SAARC countries. And in context of mass flow controller, we are like Corning's, we salute your new growth or opportunity in India. And we also started a few years back with our first mass flow production center. Although we don't do semiconductor grade mass flow controllers, but we manufacture the mass flow controller which is very much adapted to the Indian domestic market. Other than that, as I showed you earlier, in Nagpur and Haridwar also we have facilities where we do manufacture our other products in medicals and in our energy and metals. In academic institute, I'm an application scientist, and not only me, I have a team, and we work with premier institute like ICEA and IIT, where we have our own application lab, and we do use this application lab to be connected with the current research trend, as well as we help the industry in their R&D activities. Now, coming back to the main topic, or the solution which I wanted to introduce in this platform. So if I talk about the materials and semiconductor segment of Horiba India, we have large different varieties of instrument. Okay, it's all the way from main manufacturing segment, where big tools or what applied materials or lab research provide. As I said, if the main component parts of it, that comes from Horiba. Those process monitoring and controlling equipment that we provide. Beside that, we also provide QC tools like spectroscopic ellipsometer, Raman, AFM Raman, and different kind of tools. Not only that, in the utility section, our ultra pure water solution, chemical concentration monitoring solution, these are the equipment also we provide to all the fab worldwide. Now, we heard about I mean, we all have shown in our presentation. I don't want to show it, but we cannot avoid the fact that QLED, OLED, these are the new emerging technology, or maybe we can take that this is the current trend of display technology. Whether this or the future, what is coming, this flexible, transparent, all these kind of screens, whether we talk about those also, one thing is important. If we want to make it cost effective, we have to work on the quality controls, process optimization, and their performance. That's the one way. Maybe that could be one solution to bring micro LED to, yeah, it is a far-fetched dream to bring it to LCD levels, but maybe we can make it a little bit more cost effective by doing this analytical engineering. And I have the solutions for that. So with the Horiba technology, what you can do material analysis, which are important. I will show in the next slides and all, taking one example as micro LED. We can also work on the process optimization with the Horiba technology, or in the utility section with different chemical concentration monitor series or UPW, I mean ultra pure water products of ours. Little bit more detail if we talk about, let's say we want, if you're working in the cleaning process, where we can give you different type of chemical concentration monitors. We have 60 variants of it, from phosphoric acid to different combination of acids, pH monitors and other things. Here I'm showing the solution in our chemical concentration monitor series. This is the inline as well as offline is also possible. Means you can have a combination of different acids, and you can monitor at the same time 6 different variants of it with the inline line. Now, if you want to do it offline, there you can do more with 8 variant types. And let me tell you, this is really unique, and only Horiba can do such wide variants at the same time monitoring. Deposition systems. This is not only semiconductor, I think display industries also, where the epi layer is forming. Let's say, for example, micro LED. If you want to grow a GaN epi layer, it will involve a different deposition process chambers. So in the deposition process chambers, to monitor, to control, or the process optimization, we provide different type of solutions in the fluid control, or for pressure regulating, or maybe just cleaning the chamber, those kind of solution also there. And these are some flagship products which we are continuously having a good face in the semiconductor industry as well as display industry. Our mass flow controller, CDG, RGA, residual gas analyzer. So basically this is a mass spectrometer in 150 mm size. It can actually, yes, it is 150 mm size. It can directly go to a process chamber to find out what are the components or any gas molecule, any impurities is there in the chambers. Similarly, IT thermometers, IR 400 is again, it's a gas monitoring system, and mix injection. In fact, many of our this deposition component level tools, we have made it for specifically for our OEMs, and one such is MB2000. It actually came with our applied materials, one of the project, and later it became very known to the semiconductor industry. This is a mixed injection system to deliver the precursor, liquid precursor, directly to the chamber in a vapor form. It's a very interesting product. And all these products we have also in live demo in our booth 424. So if you guys have some time in between, would love to host you there. And in the facility tools also, whether airborne molecule monitoring system, exhaust gas monitoring system, wastewater analysis, it's like a complete care of your fab that you can do with Horiba system. Now, making a material is one, and at the same time, for the cost effectiveness, how good the yield is, that is need to be checked continuously. There comes the material characterization tools into play. And here we have our expertise, and we have spectroscopic ellipsometer for thickness analysis. We have XRF analyzer, which can do thickness analysis, and it also has a transmittance mode, so you can actually find out if anything is layered inside in a bulk structure, as well as find out the elements, because it's ultimately a EDXRF tool, so you can find out the element, what is present in that thing. We have PL system, which can give you band gap defect information. In fact, it is important, if you are working on the R&D, I will show you in my couple of next slides how important it is to have a spectroscopic inspection of your material, because it saves a lot of time. You can see you can see without destroying your sample. For example, this micro LED, so normally we all know, first you make the chip and then on a epitaxial growth substrate, and then you transfer it to back panel, right? Now, when you are growing the epi layer, that time the defects, whether it's originated during the process or before if in their presence, those are yield-killing defects. And when we are talking about micro LEDs, this era, it's a very high pixel density, right? Traditional electroluminescence not always will help you. And there comes your savior is a PL. So what it does, you can actually find out the entire wafer PL information, and from there each after each pixels, what is whether it's a dead pixel or if there is a illumination, some less brightness, you can find it out. This is one such example, I'm showing it to you. It's a high resolution PL map, and if you can see my cursor, this is a defective PL. That's why the brightness has gone down, because any defects, the emission will be in a different peak position, not in ideal one. So that is why when you take that peak and try to map it over entire panel, you will be seeing a dead spot there. And that's how you can find it out, which pixel is dead. Beside this ellipsometer, I know the time is very short, I cannot go in detail about this analysis, but just wanted to give you a glimpse, and maybe we can have a discussion over the dinner section or the booth. So this is an ellipsometer. Here also, this is our pioneer, because we are the first inventor of phase modulation technology. And this is just, I will talk about this one, because we talked about glass, okay? So SiO2 on a glass substrate. So SiO2 on a transparent substrate, still it can measure the presence of it in such a low dimension. So you can also find out refractive indexes and other optical properties. So what value I am proposing here, that Horiba has technologies, multimodal technologies. You can do not only one inspection, more than one inspection together from one instrument. We have technology for looking into the entire wafer, or maybe in a micro dimension where to a single pixel size. And the third part, this is my portion, where with my team we have the application experience. And I think in the ecosystem, when we are developing the ecosystem, it is important. People who are already handled the technological expertise, it's always handy to when we are going in such an adventure. So with that, I will conclude. So Horiba, as we discussed, that it's from lab to fab, we have our technology, mostly in analysis and testing solution. From each step it can cover, what would help in your yield challenges, okay? And we are here in Horiba, India, our offices overall, we are here to local support with our application experience in the field. With that, I would like to thank you. I hope I have not taken much time.
You have not. Joy and fun. Presented well. The analytic engineering and the MFC strength of Horiba. Thank you, Dr. Priyadarshini. We'll just proceed to the next one, Vasu. Let me introduce Dr. Vasu Kulkarni to the group here. Dr. Vasu is from AMiC, US, and he will present his polarizing film solution, something which will have a huge market opportunity here. Vasu, your audience. Your floor.
Okay, so I want to take this opportunity to thank the SID India committee to accept my paper, and also all of you here sitting in the afternoon and wanting to take your break, right? So I'll try to make it quick and you can have your break. So the topic is development of melt extrusion polymerizing film or polarizing film. And as you heard from many of the previous speakers, film is one of the important part, and we don't import a lot of, I mean, we import 100%, we don't make any of these films, right? So it's very important that we have this technology to go ahead and not only make the film which is currently, being imported, but we also want to make sure that we don't use the films that are made, maybe look at the advanced part of it, the next generation, so to speak. And so what I will do is cover those topics, okay? So I'll give you a reason for why we should have the film. Second, I'll give you a little bit of commerce, and I might end up what I would call skip over some of that because you have heard so much of the commerce part of it, okay? But let's dwell a little bit on the technology and then give you some strategy of how we are going to go ahead and develop this, okay? So here's the purpose, right? I mean, the reason why we really want to not just use the existing film technology that may be there is because there is a constant interest in trying to lower the cost. And as you heard, there's a lot of competition that goes around from China or from Taiwan and so forth, right? So why would you want to get into the same kind of situation if you buy this, bring in that technology and use it for your LCD films or OLED films, or it doesn't matter what films, but you would rather want to use something next generation and see if you can get that and make the board, right? So what we have developed here is proactively go on thinning the film. So that will reduce the amount of material usage. Hopefully you will have lower cost, and that's one way to go about doing that. The second thing is to combine the technologies currently where core and the skin is being made. We're saying, why don't you add them all together and see if you can simultaneously produce the film rather than producing it separately and then binding them together, okay? And so lastly is the process itself is such that it's a wet technology, and we are suggesting that maybe you want to try the dry technology to do this, okay? So I'll share a little bit of the details. So at the bottom, as you will see, that there are different S curves. That means every time you want to build up the next level of next generation of curves, right? So we are trying to see what's the next generation here, okay? This I'm going to skip because you've already seen the exploding market and so forth. Here I'm going to spend a little time that you will see there are a few producers of the films in the world, and it's almost 1,000 million square meters of film that is produced a year. That's a lot of films, okay? And you will see the major producers, but you will see a couple of them shifting dynamics in terms of producers were large, they are now shrinking, and it's really being taken over by a few of them, which is in Taiwan and China, as a scaling up and larger producers, right? So you really want to be careful about what technology you bring in and how you're going to be able to sustain and grow it and compete, right? Here is the chain. When you look at the chain of these supply chain, you will see the polarizing film producers, there are panel producers, and the TV producers. There are only few of them who can do all of them together. Not everybody does it. So buying components from different companies and then trying to assemble it, or even building an ecosystem like that, would not be worthwhile. You need to be integrated to maintain your costs and manage and give the best quality product that you can, okay? To give you a structure of the model, right? So the module has several films, as you can see, but the ones that I want you to focus on is the one which is in green, which is, number 1 and 2. The current polymer polyfilm that is being produced, you will see is quite complex in terms of it takes the PVA, it has the protective layers on both the sides, and then it has the iodine, which is the material that is used, and then you have to stretch it in each directions, both the directions, and then produce the film. What we are suggesting here is to combine that and do the extrusion polymer film in one shot and then go ahead and produce your film. I'll show you a little details of how that would work, okay? So if you look at the current films, and if I split them up into what the components will be, you will see there are layers of it, okay? And you will see the tack layer, it could be PET also. You could see the polyvinyl alcohol, which is the PVA layer, and you will also see the PSA, which is the adhesives, right? And the release films and protective films and so forth. What we are suggesting is that if you have got so many films and you're bringing them all together and trying to formulate it, it's quite an expensive and arduous process, right? So let's look at the process for what they're using today, and you'll see how complex it is. You have to start with the pre-treatment, which is where the high amount of water is being used. Then you will have to stretch laminate it. You put in the protective films, you coat it with the PSA, and then you size it up, and then you would inspect it and ship it, right? There's quite a few of processes there. And what we're saying is, instead of all these so many processes, why don't you go with one single process? And we have developed that and we have patented that process, okay? And this is what we would suggest. We would suggest that we should bring into the next generation of film, and that would be requiring us to use the ion nodules, which are molecules, which would be embedded already in PMMA, and you just extrude it, okay? And when you do that, your process will be much simpler. And you would take the core PMMA, bring in the drying of PVC, extrude it, transfers, and machine direction, you stretch it, wind it, and you're done, all right? So what does it do? Well, when you do all that, we have technology consultants, who can bring this film developing technology. We have people where we know how to do the extrusion, so we have developed that. We have got the core technology, which is going from 3 or 4 layers to single layer, bringing it in. And we also have patented, and we are, testing it out currently in Europe with a firm. So we have the technology and we can go ahead and bring it in, is what we are suggesting, okay? And when you look at it, it will reduce your cost by almost 40%, and which is a significant cost in reduction, right? So we are saying, instead of the 3-step process, go down to the green part, which is the shorter process, and the manufacturing cost can be reduced almost 40%. And this is not a pie in the sky number. It is, we have done it and we have proven it. So it's pretty well recorded. And I'm giving you a little bit more conservative, but it's fine. 40% is a good number to access, okay? And you also probably noticed that it was a 300 micron thickness in the current process that you would have. Maybe it's a little lower, 250. But what we are suggesting is even going further down to 100 microns. So you will really reduce a lot of your, what I would call, product cost, right? Or raw material cost, okay? So the process, we have tested it here, and we have done about 100 micron thick, with the light transmission of 40% plus. Polarization is 99.9%, which is very good. And it's a capacity of 45 million square meters per year, okay? So we have pretty good system, and we have done the design. And what we are going is proceeding further. If somebody wants to invest and do this, within about 24 months, we can go ahead and give you the commercial product coming out of your system, okay? And we have done all these analysis, and this is just give you a model of how we have done and what we have done. And we have done 5-year analysis on this, and what would be your payback systems, and how we can go ahead and develop this for India or for any other place we want to produce it, okay? And so the investments, so somebody asked me about investment. So we have a slide where it gives you about $100 million you will have to start off with, which is not very big, very substantial, but you would only produce about 45. And if you want to go and scale it up to further, of course the cost will be different. The analysis is done for about 45 million meters square per year, which doesn't add a whole lot to the 1,000 that you saw, the global market. So markets are not going to be changing. You will have what you need. And you will have at a very competitive or low cost production facility, okay? That's what I had, and thank you very much. I hope I didn't take too much of your time. All right.